Okay, so we were okay with when part A was kind of tricky. We first of all realized, well, if that's 80 degrees and the whole thing is 152 degrees, so that's 72 degrees there. Um, and we worked out these distances, 75 and 60, by using the distance equal to speed times time. That's a v is the symbol for speed, also the symbol for velocity. And we therefore, using the speeds down here and the time, which is 3 hours, we saw that the distance there is 75 kilometers and this is 60 kilometers. So taking a simplified diagram here, we applied the cosine rule, which I'm not going to go into too much detail here, but we got an answer of 80.27. So it's the second part that which we're interested in, 80.27 kilometers. Let's move this out of the way as well. Okay, let's try that again. Right. So the thing we're now struggling with is to work out the bearing of a of B from A. So in other words, what direction, if I'm at A, what direction is B? So the angle that is referring to is this angle here. Now, if I just do this angle down to here, so I've extended the arrow down, we had to know to draw the arrow in the first place, but if I extend it down, we know that's going to be 180 degrees. So it's just this extra little bit we'd have to add on to the 180 degrees, and that would give you the answer to this question. To work out this, what we did is we first of all identified this angle as 100 because these two north poles would be parallel, and therefore these two are called co-interior angles and would have to add up to 180. So that's 80, so that must be 100. Now we know that these two, the pink angle I've labelled and this one in black, must add up to 80. So we can work out this pink angle using the sine rule, and then we would know to subtract that from 80 to work out this angle. There are other ways you can eventually, just remember we're trying to work out that angle, so we could do it eventually. But we do need to work out this pink angle. So let's go to the simplified diagram here. I'll do it in pink again so we can follow it more easily. And we'll also label the 80.27. Let's just take this and copy it. So we reckon actually we don't have to use it because we've got three sides and we're working with two angles. We could use the cosine rule as well if we wanted to, but I think the sine rule is easier. So we'll call this, let's call it x. So we can say the sine of x divided by the side that's opposite, which is 60, is going to be equal to the sine of 72 degrees divided by the opposite side of that, which is 80.27. So rearranging that, we can say that sine of x, let's just extend this a little bit. But if I multiply both sides by 60, I can say sine of x is 60 sine 72 divided by 80.72. I don't want to know sine of x. I want to know x. So x would be equal to the inverse sine of the right-hand side. So let's just put all that in square brackets. So once I've got that value for x, which is the pink angle, what I would probably do is add it to 100, then take those two away from 360, and that would give you the rest of the angle. So let's see. So we've got. So I think, yeah, I'm just looking at the answers here rather than tapping it into my calculator because we're going to run out of time. So we should get 45. I'm going to do a few different significant figures so as to reduce the error. And then what we do, if we add, so 45, essentially we're doing the whole, if we go around the whole circle, then we can say the angle, the bearing, which is going from here all the way to the green line, is going to be 360 degrees minus 100 degrees minus that pink angle, 45.308 degrees, which ends up being to one decimal place, which is how you should do angles, is that. So that's the answer.